I get this one set up. So equals, and then you just want to kind of leave in, I kind of put a dot in each space so I know where I'm writing the answers. You want to give me the answers here, work it out, and I can write the answers and compare.
Would be the top -7, 4, and the middle would be 1 and 7, and the bottom would be -2 and 2.
You got it. Now, did your instructor talk about something like let's say I wanted in the answer element 2, 1. Did you guys talk about that at all?
No.
Okay. Is this maybe just the start of matrices? Or is this the full, full on everything?
Well, I mean, as the questions get pretty complicated.
Okay.
I think this is the only matrices stuff we're doing, though.
Okay. Is there more than what you sent here? Because you're moving to equations and then some systems, but like there is other matrices stuff that's typically covered early on. That's why I asked about that E business. That's okay. If you're not covering it, you're not covering it. So this is a scalar on the outside. It's called a scalar multiple. So you just take that number. It's basically like the distributive property, distribute it to both. So you're multiplying -3 times 0, -3 times -2. This is how you would show your work. 0, +6. So it multiplies every entry. Doesn't matter how big or small the matrix is. You in fact do it that way. So let's go to number 5. Okay. So order of operations still applies. They're trying to show you, and I'm going to do it in red here. They're trying to show you these are like parentheses, like do this first. Okay. So it's good to maybe build that one. Since I don't have it for my screen, I'm going to build it off to the right and then drag it down. But it's going to be 4y minus 2x as a single entry there. We don't know y or x. It's going to be -3y plus -2y, so -5y. 3 plus x plus 3, so x plus 6. Z minus 2x plus x minus 2, so the x's combined, z minus x minus 2, like that. Any questions on that, combining that?
Nope.
Okay. All right, so let me just drag this down. It's a lot like, they call this like matrix algebra. It's a lot like, showing your steps below. Like this, and then it's minus. So when you subtract here, it's 2 minus 4y minus 2x. Okay, and you can either choose to like distribute the negative now or wait until the next one. The next line becomes 2x plus 5y. And then it's 3z minus x plus 6. 6 minus z minus x minus 2, like that. And you actually have your choice. You see these often in brackets. They can also be shown in parentheses, but it looks like you're pretty consistently using brackets here. So I'm going to grab this, bring this down to simplify in the next line. So this becomes, and let me just order it so that x comes before y. So 2 plus 2x plus 4y, 2x plus 5y. This third line here becomes minus x plus 3z minus 6. And then this last one here, if you need to, you can distribute in here like -7 plus x plus 2. So it becomes x minus z plus 8. What they sometimes do is they'll actually like have this equal to something here so that you can actually find the values of of X, Y, and Z. But it doesn't look like you're doing that here quite yet. All right, so I'm just looking for the next problem here. Six, we're up to 6, right?
Yeah.
Okay. This is kind of like the one earlier, it's distributive property. This 5p distributes to everything. Well, I'm sorry. This is, I should take that back. This is one term, and then this other one over here on the right is a term. So it's 5p times 4 minus 3q, like that. And then on the right here, it's 5p times minus 2rq. And then these are the two elements in the matrix here. Okay, so on the left here, you do have to distribute that 5p to both of these, but it's because this is a term. So that's 20p minus 15pq. And then this one is minus 10 q pqr. I guess that's the right order there. And you want to show them with enough space to like indicate that it's two separate entries. If you're not real good with that, you can use parentheses to sort of separate them there like that. So 7 is next. This is the first one that I think, requires probably like more explanation. The rest probably are very intuitive. Multiplication is very different in matrix land. All right, so first thing is when you multiply matrices, you start by writing the row by column of each. It's always row by column. And if you've been to museums, you know that columns go up and down. Probably seen that on museums. Rows go left to right. What has to match, and you probably heard this in class over and over again, these have to match right here. If these don't match, there is no way to multiply them.
Yeah.
The outside dimensions tell you the dimensions of your result. So you have to draw a 2 by 2 matrix. Okay. So we're going to have 1, 2, 3, 4 positions to fill when we multiply these. Any questions on the setup?
No, it's pretty easy.
Okay. All right. So let me show you the first couple here. So it's row by column. Okay. So to get that first entry in your answer, the first row in the first column, you take the first row on the first matrix times the first column on the second. So that's -1 times 2 plus -5 times 5. And that becomes -27. Is that okay?
Yeah.
All right. And you've seen this before a few times?
Yeah, I have.
Okay. So I'm going to show the shading here. So let's say we wanted, let's say, well, I'm going to get the one down here in the lower right. So it's second column, second row. That gets you over here on the right. And actually, let me shade this one here. Sometimes it's unclear how these are gotten, but it's then 3 times -5 plus -4 times 1. And this gives you -19, it looks like. To get either the other ones, my shading kind of falls apart here because I've got gonna have to overlap, but let's do that here. Let's say I wanted the first row, second column. That'll get me this one here. So I take that first row, which is -1 times -5 plus -5 times 1. So that's 5. That ends up being 0, it looks like. And then I haven't used them all. And then to get the one here, you go second row, first column. These are the toughest to do by hand. There's really no way to get around doing it this way. So 6 minus 20 minus 14. What do you think about that?
I mean, yeah, he did it the same way, except he didn't. It was a little confusing, but I kind of get it now.
Yeah, I'll do a better job of color coding them here. But basically I just have to take more time here. So here's what I want you to do. I want you to do, well, let's actually first make sure that this works. This is 2 rows by 3 columns. 1, 2, 3, 2 rows. And then the second one is 1, 2, 3 rows by 2 columns. And the inner dimensions match. So your resultant is a 2 by 2 there. Okay, so your answer is a 2 by 2. So let's do this first one here. First row by first column. Go ahead and give that a try, please. First row by first column.
Is it negative 45?
Give me just a moment to get caught up to you. I'm a little behind here. I was trying to debate how to do this. It is negative 45, yes. Okay. All right. So now what normally you do, I'm gonna reframe the question here. So we know the top one is negative 45. So you have to decide, are you more comfortable moving to the right or going down? Like which kind of is more intuitive to you, the right one or the one going down? There's not a right answer here, just whatever you like.
Probably going to the right.
Okay. So this one is first row, second column. Do you see that? First row, second column. So first row, second column.
Oh, okay, now I get it.
Okay.
Is it?
Yep.
Yeah.
So go ahead and work that one out for us, please. It's really important that you be able to do this because it's going to be on the test. You will be multiplying.
It's negative 4.
You got it. Negative 4. Perfect. Okay. All right. So let's do this one more time here. So you would probably naturally then move down to negative 45, negative 4. So let's go to, so you want the one in this position. That's the second row, first column. So second row, first column. So notice the rows always comes from the first one. The columns always comes from the second one.
Yeah, they match.
Yes, exactly.
It's 23.
It is 23, good. And then the last one there, you can probably see it, but I'll copy it down anyway. One of the advantages of having the digital screen here is I can just replicate this over and over again, so you can do it visually right. So the one in the lower right there, you want to see it as second row, second column, second row, second column. On yours, you won't be able to reproduce this. You gotta just maybe circle it, but do it in very light pencil. Circle it in very light pencil. That way you can erase or rewrite it a couple of times.
So that would be negative 42.
Yes. Very good. All right. So maybe, maybe practice, 7 again if you want on your own or something. Maybe you've got some other ones that are like it, but you definitely have something like that on the test here. The next problem I see on your list here is number 11. Let me know if that matches up with what you want to do next.
Yeah, it does.
Okay. So the determinant is what this notation means. It means determinant. I actually don't know if I'm going to spell it correctly. But if you're given elements A, B, C, and D, the determinant is AD minus BC. So basically it's kind of this butterfly multiplication. So in your problem, it's 3 times 3 minus 0 times 0, or 9. Sometimes, I mean, there's so many questions I know that could be asked here, but do you think you'll just get a straight, calculate the determinant, or something more?
It should be just like that.
Okay. All right, so the 3x3 is more difficult. There's two approaches here. The first one is, I think, probably what they teach in class. I don't really know. I don't like this approach, but I think they have you like rewrite some of the columns.
Yeah, you rewrite the first two columns on the
Yes.
other side.
So I don't use this approach. So, but I remember that I believe they want you to multiply diagonally.
Yeah.
Okay.
So,
I can look this up too. So when you multiply diagonally there, you get 0. I think you'd have to do some sign changes though. Is that right? Like this one's plus, minus, plus.
yeah, you go the other way first, I think. So
Okay.
you would go 0 times 3 times negative 2, and then negative 3 times negative 3 times negative 4, and then negative 5 times 2 times 0.
Okay. Why don't you work this one out, and I will do the same, and we'll compare answers here. And if you need me to, I can look up this method more specifically. There is a better method, but this is what I think they teach in school.
I got 6.
Yes, very good. So it looks like it's bottom minus top. That's the way you guys have been doing it in class there.
Yeah.
Okay. This actually violates some other things that are common in math. One reason I prefer not to show it that way, but you have the test. You have to know how to do it. All right. So it looks like maybe 15. Is that right?
Yeah.
Okay. There's two ways to do 15. There is using formulas, and then there's also the Gaussian elimination way. You probably used formulas. So the inverse here, you first have to take the determinant of the matrix. So sometimes they just show it as AD minus BC like this. Does this look familiar to you?
Yeah.
Okay. And then you swap and then negate. And I always have to look because after you do this once by hand, you almost never do it again. So you end up swapping A and D, negating B, negating C. So the key though is this right down here. This has to be not equal to 0 because you cannot divide by 0. So if you end up multiplying the diagonals, adding and subtracting, getting 0, there is no inverse. So usually you do that first. Minus 4 times 4 minus 6 times 1. So that's minus 16 plus 6 is minus 10. So it's 1 over negative 10 times. So you switch the entries 4 and negative 4, switch the diagonals. That's what this D to A means like a swap. And then you negate the other ones. So negative 1 and 6. And then lastly, you're supposed to multiply in. So you're dividing by 10 and negating. So minus 0.4, positive 0.1, minus 0.6, minus 0.4, like that.
So the only thing is, well, that's how you do it, but he wants to answer in fraction form instead of decimal.
Oh, okay. Sounds good. So we'll change that up here. Minus 2/5, minus 3/5, 1/10. Was that one really negative? This one should have been positive. So 2/5.
Yep, there we go.
All right, so the next problem I see is 17. Does that look right to you?
Yeah. So
All right, now,
these
what
yeah,
does it
so
say? What does it say? What's the method?
solve each system of linear equations using matrices.
Okay, that could be a lot of things. So let me. All right. Is there any other wording there? Because there's two approaches. One is to do reduced row echelon form, which is Gaussian elimination. The other is to use
Oh,
matrix
he
and
says you
inverse.
can use Gaussian or Gauss-Jordan.
Yeah, that's what, yeah,
elimination.
Gauss-Jordan, yeah. All right, we're gonna slightly reorder this. But the first thing you do is you write well, first thing I guess maybe is to see that this is 0x plus 0y plus 4z equals minus 4. And we're gonna write just the coefficients. So let me do that off to this on the right here, and then I'll bring it out. So it's 2, -2, -3, draw a dashed line, minus 5. And then we're going to actually use this last equation, the 4x minus 2y plus z next. So 4 minus 2, 1, and minus 15, 0, 0, 4, and -4. Now the reason we're doing that is because this other equation is like almost solved for z. Take a look at that, make sure you're okay with my setup on that.
Yeah.
Okay. All right. Now, there's these things called row operations. Have you heard of those?
No, I haven't.
Okay, have you done problems like this before in
Yeah.
class? Okay, okay. I'm asking because I mean, that's really the only way to do this. So the row operations, you're going to take row 3, you're going to divide it by 4, and that's going to become your new row 3. Okay, now why are we doing that? Because you really want a 1 in this lower right position. Because if you have a 1 in this lower right position, that's the variable solved for. That's Gaussian elimination. And really, we should have been doing this on like a 2x2 to start out, but since this is the only problem you sent over, I mean, we'll just go with it. So then you do a lot of rewriting. So what I recommend is kind of this flow where on the right is like kind of your show work side, and on the left is your result. So what this also means when I say row 3 divided by 4 becomes your new row 3 is that rows 1 and 2 are not changing. They're just staying the same. This last one was 0, 0, 1, -1. And what that means here, this last row means that Z is -4. I'm sorry, -1. Is that okay? Clear what we're doing?
Yeah.
All right. Now I have the advantage of being able to use a lot of real estate here when I do it. These do take a lot of writing to do. So the next thing we will be doing here is we're going to use this 1 in this position to clear out these in the other positions. Okay. So to do that, I'm going to take row 3 and multiply it by -1. Okay. I'm going to add that to row 2, and that will become your new row 2. Okay. So we're going to show that in steps here. So row 3 times -1 is 0, 0, -1, 1. Row 2 is 4, -2, 1, -15. And now we're going to add them together. 4, -2, 0, -14. Is that okay?
Yeah.
So that becomes your new row 2. Now we're not going to make any other changes. So row 1 stays the same. Row 3 stays the same. But row 2 is now 4, -2, 0, -14. Now we're going to use that 1 again in row 3, and we want to clear out this -3. So to do that, you take row 3 and you multiply it by 3. The reason is we really want a 3 here. We're going to add it to row 1, and that becomes your new row 1. So that's 0, 0, 3, -3. That's me multiplying row 3 by 3. I'm going to write row 1. We're going to add them together. 2, -2, 0, -8. So this means that row 2 is the same, row 3 is the same, only row 1 has changed. Only row 1 has changed. So that's, and I like to rewrite the rows before I put in the new one. I found that works a little better. 2, -2, 0, -8. So our goal is to get a 1 in this position here, and then a 1 in this position here. All right. So we're really kind of close, actually. So if we could get a 0 here, we would be in really good shape. Like maybe I should have started out by saying that. Like our goal here is to get this down to where it's 1, 0, 0, 0, 1, 0, 0, 0, 1, and then numbers on the right. That's our goal. And this one
Is that
actually,
always the goal?
it's always the goal. And this one doesn't work out that nicely because like normally you get it where there's actually you actually make zeros down the first column. Like there's an algorithm, you make the zeros down the first, but we can do one that does work out a little nicer. So just follow along, I guess, for now. We're going to take row 1 times -2, because that's going to get you a 4 in this first position. -4, and you're going to add it to row 2 to become your new row 2. So row 1 times -2 is -4, 4, 0, 16. Row 2 is 4, -2, 0, -14. You're going to add these together, and you're going to get 0, 2, 0, 2. This is starting to come together. 2, -2, 0, -8. 0, 0, 1, -1. 0, 2, 0, 2. So we really want a 1 right here in this position in the middle here, because then it's 1y equals whatever number this is. So you can see that we're going to take row 2, divide it by 2 to become your new row 2. I know it's a lot of rewriting. There's a lot of numbers here. Most of them are not changing, but that doesn't really help. It's just a lot of numbers to be staring at. Okay, we're in really good shape here. So we really want a 0 up here in this position. So to do that, we're going to take row 2, multiply it by 2, because that gets us a 2 here, 0, 2, 0, 2, kind of like back where we were. We're going to add it to row 1, and that's going to become our new row 1. So, well, I need to show that 0, 2, 0, 2, 2, -2, 0, -8. I'm going to add those together, 2, 0, 0, -6, and that's your new row 1. Two, 0, 0, -6, 0, 1, 0, 0, 0, 1, 1, -1. So we're almost there. To get a 1 in that top left position, you divide row 1 by 2. That becomes your new row 1. So that becomes 1, 0, 0, -3, 0, 1, 0, 1, 0, 0, 1, -1. So this means that x equals -3, y equals 1, and z equals -1, like that.
So what process do you use to find out like what you want to do with the rows in order
Yeah,
to get them?
yeah, that's a good question here. Let me find a better problem to kind of show you the more general process. This one was sort of handpicked to kind of work out nicely, but it really isn't. So generally, let me just say generally here, generally you want a 1 in this position. And you can get that right away. Like no matter what's here, you could divide by that number to get a 1 in this position. You use that 1 to then get a 0 in this position, in these positions. Like that's generally the path that this goes on. And then there's another number here, 2, 8, and something, 6. So then you want to get a 1 in this position, and then you use that to get a 0 in this position. So when you do that, you've got other numbers here, 3, -10, whatever, and you've got some number here again. We'll put 8. 5, 3, -4, but then you get a 1 in this position. So like you start by getting 1 here, 0, 0, then you want a 1 here to get a 0 here, then you really want a 1 here. Once you get that, you can use it to go backwards and get a 0 here and here. Then you can use this 1 to get a 0 here. So you typically work down, down, up, up, and lots of things change along the way. I'm happy to find a better example for us. Or if you have another problem, we could try it on that as well.
I don't really think I have a better example. All of these are kind of like the last one.
Okay. So here's a better example that illustrates exactly what we just talked about. All right, so here is the system. Okay, so you start by drawing what's called the augmented matrix, which is the matrix without the letters. I like this dashed line between there. Some people don't show it, some do. You can take whole classes on these. I think they're very interesting, but you're kind of just getting a primer starter here on this. So notice how there's a 1 in the top left.
Yeah.
We're going to use that 1 to get a 0 here where the 2 is and a 0 here where the 3 is. So we're going to take row 1 and multiply it by -2 because that's 2. Add it to row 2, and that's going to become our new row 2. So this becomes new row 1 is, I'm sorry, the row 1 times -2 becomes, and I'm multiplying each of these entries by -2. -2, 2, -2, -16. Row 2 is 2, 3, -1, -2. I'm going to add those together, 0, 5, -3, -18. Is that okay?
Yeah.
That's your new row 2. You're keeping row 1. So some students even write like keep row 1. Now we're going to take row 1 again and multiply it by -3 now, because we want to get a 0 here. Row 1 times -3 plus row 3 becomes your new row 3. So you're not working on the modified one. You always go back to the original here. Row 1 times -3 is -3, 3, -3, -24. Here's row 3, 3, -2, -9, and 9. Add these together, 0, 1, -12, -15. So we're keeping row 1, 1, -1, 1, and 8. And our new row 2 is 0, 5, -3, -18, 0, 1, -12, -15. Is that okay?
Yeah.
All right. So I'm just rewriting it here. So I've got some screen to work with. Now we really want a 1 where this 5 is, and you are allowed to now swap rows. So you really want a 1 there, and you'll see why in a moment. So I'm going to just swap the rows. My thought bubble here is like, this feels like a game where you change the rules as you go. Because I'm like thinking, well, why does this even work? You know, it just does. For now, we leave it like that. So you really see how you want a 1, 0, 0. We got that. Now you want a 1 in this position. So then you want to get a 0 where the 5 is. So to do that, you're going to take row 2, multiply it by -5, and add it to row 3, and that becomes your new row 3. You're keeping rows 1 and rows 2 this time. All right, so row 2 times -5 is 0, -5, 60, 75, 5, -3, -18, 0, 0, 57, 57. That's good. Let me know if this is okay. Clear.
Yeah, I got it.
Okay. So here we go. We got 1, -1, 1, 8, 0, 1, -12, -15, 0, 0, 57, 57. Oops, let me not do that. You don't use those. All right. So now we really want a 1 in this position here. So we can take row 3 divided by 57 to become our new row 3. It should work out nicely. Okay, so like if you get something that doesn't work out nicely, you've made a mistake. And if you've made a mistake, you really got to go back to the beginning. It's really hard to trace your errors here. Okay, we really want to one in this position. We now have it. All right. So let me save a little time here. Let me copy and paste. I don't want us to run out of time here before we get through this one. All right. And notice you're dividing everything like all the entries, 0 divided by 57 is 0, right-hand side divided by 0. But this is really important. This is called upper triangular form, I think, where there's zeros on the bottom here. That's what you want. You want to see 1, 0, 0, 1, 0, and 1. We are now going to put zeros in these two positions. Like our goal is to get zeros there now. Okay, so to do that, we're going to take row 3, multiply it by 12, and add it to row 2 to become your new row 2. Is that clear why we're doing that?
Yeah.
Okay, so it becomes 0, 0, 12, 12, 0, 1, minus 12, minus 15. We add those together. And that's your new row 2. And then similarly, we're going to do row 3 times -1 because we want to get a 0 up here in this other green. And it's +1, so I got a -1. Add it to row 1 to become your new row 1. You're almost always adding it to the row to become the row. That's almost always happening here. So we got 0, 0, -1, -1. Then we're and we're adding that to row 1, 1, -1, 1, 8. I strongly recommend this flow of work result on the left or vice versa. So this becomes 1, -1, 0, 7. Now we can rewrite our answer here. So we got 1, -1, 0, 7. And then 0, 1, 0, -3. And then we keep row 3, 0, 0, 1, 1. Any questions on that?
Nope.
We're almost there. Believe it or not, we are almost there. So we're going to take row 2 and just add it to row 1 because once we do that, we get a 0 there. So row 2, add it to row 1 to become row 1. So I guess I can show that off to the right here. So we've taken almost 7 minutes to do this problem. These are going to take you a while. So plan on chunking out, 10 minutes for one of these on your test. Oops, sorry, I need to add them up. 1, 0, 0, 4. And yours should all work out nicely. You shouldn't see anything weird in your class here. Y and Z. All right, well, we hit the goalpost there. We're all done for today. Go ahead and stop the recording here.